Hello, class. This will be a continuation of section 6.3 of exponential functions. The previous recorded lecture talked about graphing. Now we're going to talk about manipulation in the algebra of the exponential functions. And I'm going to show you a slide that will come in quite handy for those of you that are just seeing this for the first time. So if you look on the slides that have been uploaded, you'll see this is slide 16, and it gives you kind of the laws or the rules for manipulating exponential functions. And again, it's really important that the bases are the same, as you can see. So A is the base. And the ones that are really important is that when we have this minus here, right, a to the minus s, you see that the base goes down into the denominator. So you flip it. And the same thing happens that if it's in the denominator, it comes back up into the numerator. We see when we multiply two together, we add the bases, or excuse me, when the bases are the same, we add the exponents. And we take it to a power like this, s to the t power, we multiply those two together. So let me kind of illustrate that with a couple examples here on the whiteboard. So let's do something that's pretty straightforward. So say like we had 2 squared times 2 cubed. So the first thing you can do is write all this out, right? So there's 2 2's here, right? And there's 3 2's there. And so you write all that out. You count up the 2's and you see that is 2 to the 5th. And so that's what we mean by addition here. That would be 2 to the 5th power, right? But say like we did this, 2 squared and then cubed. And so when we do that, you write it out this way, right? 2 squared times 2 squared times 2 squared. That's what we mean by cubed, right? And you could see now, if we write all that out again, you would have 6 of them, right? 1 and 2 for each. And what does that equal? 2 times 3 equals 6. So you could see this is 2 to the 6th power. And so those are two that we're going to be using quite a bit. The other one would be this, right? Say like you had this 2 cubed times 2 to the minus 3 power. All right, well, let's think about this algebraic wise. So again, if we just follow our rules, right? This would be 2 to the minus 1 power, and that would look like 1 over 2. Because we add those together, we get minus 1. But how does that look? Well, remember, the minus brings it down, so it looks like this. So this would be 2 and then cubed on the bottom, right? And you could see we have 2 on the top and 3 on the bottom. So when you do the cancellation, there's none left on the top, and you have 1, 2 left on the bottom. So we're going to, during the homework in this section, a lot of manipulation, being able to do calculations like this using these laws of exponents. And the 3 key ones: when you multiply 2 together, you add the exponents. When you take something to a power, you multiply the exponents. And when you have a negative, you flip it. So whatever is in the denominator goes in the numerator, and whatever is in the numerator goes down into the denominator. So with that, we're going to take it to kind of the next level and do some solving some equations like this. So in this section, we're going to have to solve equations using what we call this base property, where if the two bases are equal and you have exponents, right, then the two exponents have to be equal. And so we'll be able to solve this equation using that technique. But you'll see that there's no way in a nice closed form to make the base 3, the number 3 and 20 have the same base. And you'll see that we need the inverse of an exponential function to solve that. And that's what we're going to introduce in the next section, called log functions. And in my humble opinion, log functions were invented to solve exponential functions that look like this. But we're going to manipulate the exponential functions first. So let's take this one to start with. Equals 64. And so the strategy is, and especially in this section, make the bases the same. And so can we make 64 2 to some power, right? And that will make the bases the same. So I get my hand out and count. 2 times 2 is 4, and then 8 is 3, 16 is 4, and 5 is 64. No, 32, and 6 is 64. So that would be 2 to the 5x equals 2 to the 6th power. And so now, since the bases are the same, 5x has to equal 6. So then we do back to our nice algebra that we're used to, divide each side by 5, and you'd see x equals 6 over 5. So you see, when you walk through these, you'll be able to do some of these types of calculations. Let's do one more. So say like you had this one. Well, we're going to do more than one more, but let's do this one next. Again, let's stick with the 2 number. 3x minus 7 equals 32. So again, 32 should be 2 to the 5th power, right? And get out your fingers and figure that out. And so you could see that 3x minus 7 equals 5. 3x, bring minus 7 over and add that, you get 12. And you could see x would equal 4. So, the strategy is trying to make the bases the same. So let's do a couple more. Let's try this one. 3x plus 1 equals 81. And so 81 is 3 times 3 is 9. So that's 2. Times 3 is 27, is 3. Times 3 is 81. So it looks like that would be 3 to the 4th power, right? And so that would be x plus 1 equals 4, x equals 3. Let's try a little trickier one. Let's try this one. 4 to the 2x minus 1 equals 8 to the x plus 3. So what do we do with this one? Well, looks like the 2 is the key number, right? Because 2 squared is 4, and 2 to the 3rd is 8. So you want to look at it this way. 2 squared to the 2x minus 1, and this would be 2 cubed to the x plus 3. So you could see this equals 8, and that would equal 4, right? So now we have the same bases. So what do we do when we have a power to a power? We multiply, right? So this would be 2, and that would be 4x minus 2. And then we multiply here, and you get 2 equals 3x plus 9. So when you do this, you set the two equations for the exponents equal to each other. And we'll bring the 3x to the other side, you get x. You bring the minus to the other side, and you would get 11. Okay, just going to plow through a few more examples, make them a little bit more complicated. And so let's take a look at this one. And I just took this one right out of the book. I actually like these kind of problems way better than the graphing problems personally. But that one's pretty crazy, right? So what do we do with all this? So the key is you want to combine the exponents and make one base equal the same base, and then you can combine the exponents. So the base is obviously going to be e. So what do we do with this e, 1 over e to the minus 3, or 3 power, right? Well, we can rewrite it this way. E to the minus 3 power. And that's what we mean by negative exponents. And so here we can multiply this together. And so that would be e to the 2x, e to the minus 3. And now because these are multiplied together with exactly the same base, you can add those exponents and you get 2x minus 3. So here you have x equals minus x squared equals e to the 2x minus 3. So now we could set these equal to one another. And you look at that and say, oh, quadratics. Yeah, told you, it's super important to understand quadratics. So let's solve this quadratic by moving the minus x squared to the other side. And you end up with an equation equal to 0. And since we're in a math class, you could factor this. And it would be x plus 3, x minus 1 equals 0. So possible solutions is 1 and minus 3. And so when you start doing this, especially with multiple solutions, you should definitely check and see if these work. It's like, oh, geez. Yeah, you really need to. And so let's start by checking x equals 1. So if you do that, you would get e to the minus 1. Whoops. I wrote that wrong. The minus is on the outside, so it'd be 1 squared like this. And that would be e to the 1 squared times 1 over e cubed. And so this would be e to the minus 1 power, which equals e squared divided by e cubed. And that also equals e to the 1 over e, which is e to the minus 1. So 1 works. So let's try the minus 3, see how that goes. So when you check the minus 3, it would be e to the minus 3 squared equals e to the third minus 3 squared. And I'm just going to make this e to the minus 3 power, just to make it save a quick step, right? Remember, this equals e to the minus 3 power. And so if you do this, this would be minus 3 times minus 3 is plus 9. And so we have 3 minuses, so this would be minus 9. And so minus 3 times 2 is minus 6. And e to the minus 3, which also equals e to the minus 9. So you can see both of these work in this case. Most of the time they do work, but you'll see on occasion, especially with multiple solutions, sometimes they don't. So it is important to double check your work. Okay. So let's take a look at one more example. I find this to be quite fun, but quite challenging, especially when students first see these kind of problems. So let me do one example for you. And I'll let you guys practice this in my math lab homework. So say like you're to find this equation, 4x equals 7. Then what does 4 to the minus 2x equal? Well, here's the strategy. You could, once you understand how log functions work, you could just do the logs and do substitution. But this is supposed to make you think in the sense that you want to manipulate the equation. So you want to be able to substitute that value in where we know that equals 7. So let's take a look at this, right? And let's rewrite it this way. 4 to the x and then times minus 2. So when you do that, what ends up happening, right? Well, now we have this, but to be able to make the substitution, it needs to be by itself. And remember that you could do this to the minus 2 power, right? Because minus 2 times x would get us back here. And so now you see that 4 to the x equals 7. And so when you plug that into the equation here, you would get 1 over 7 squared, and that would just be 1 over 49. I call this fun with exponential equations. So there are a few of these for you to try as well in the homework. And so that actually ends the recorded lectures now for section 6.3, which is the introduction to exponential functions.